Okay, here is our test review for Unit 12, Polar Functions. We have our formulas up here. We're not going to be using this one. And also remember that this one, you can use both of these depending on the situation. So in this first section, we are given polar r theta, and we want to convert to rectangular or Cartesian with xy. So remember, you substitute until you have no more r's and thetas left and only x's and y's. So in this situation, you're just going to focus on these two first equations. To get your x, you're going to plug in 6 for r and 2 pi for cosine, and that's going to give you 6 times 1 or 6. So you'll need your unit circle handy to do cosine or to do the trig functions. And then for my y coordinate, it's going to be 6 times sine 2 pi, which is 6 times 0 or 0. So the ordered pair is 6, 0. All right. So I want you to pause the video and try B and C by yourself. All right, here's my work for B and C. So if you want to just take a minute and check your answers, pause the video if you need to. And then we're going to go on to the next section. So the next section is the opposite direction. You're starting in rectangular XY form, and you're converting it to r's and thetas into polar form. So you're given x, you're given y. To find r, we're going to use this formula, just plugging in our x coordinate, squaring it, plugging in the y coordinate, and squaring it. So r equals the square root of -2 squared plus 0 squared. That's 4 plus 0, which is the square root of 4, which is 2. So r is 2. Then we need to find theta, and we're going to be using this equation, arctan or inverse tan of y over x. So you're just plugging in your y coordinate in the numerator and your x coordinate in the denominator. So arctan of 0 over -2, which simplifies to arctan of 0. Remember, you're not taking tangent of the angle 0. You're asking yourself, what angle has a tangent of 0? And what will happen when you go to your unit circle, you'll find that there are two angles that have a tangent of 0. So the question is, how do you know which one you're choosing? And what I do is I take the original point and I see where it is. It's here, -2. So that means that I want this to be my theta. So in this instance, theta is pi. So my r is 2 and my theta is pi. And you'll notice that the directions say to find a pair of polar coordinates. So that means we want when r is positive, and then we want when r is negative. So if I have a point at 2 theta, I'm sorry, -2 theta. Never mind, I was combining rectangular and polar directions. So 2 theta, so my theta is here and it's out 2. The negative r version would start over here on this side and then flip back over here. So it would be -2, 2 pi. Because 2 pi is here, it would be at, and then you got to go in the negative direction and back up over at the original point. So you take a minute and try C. Pause your video and try to convert 0, 7 to polar coordinates. And then, oh, and B also. Right here is my work for those two problems. I have my reference angles drawn here, so you know which one to start with when R is positive. So pause your video and check your work with mine. I will add one thing here. When this is 7 over 0, you can't divide by 0, so that's how. So what angles have undefined tangents? So that's at pi over 2 and negative pi over 2. All right, this next section, we are just graphing polar coordinates. So we have 4 and negative 5 pi over 4. Negative 5 pi over 4 is going to be right here at positive 3 pi over 4, and then I'm counting a radius of 4. So there's my point right there. Now B has a negative radius, so you start with the theta and you find where 120 is at as an angle. So it is right here on this line. But so we're here, but negative 2 means now you're going to go back to your origin, you're going to go 2 in the opposite direction. And so that's where the point is actually going to be. So on the back, we are starting with rectangular equations, and we want to convert them to polar form. So just start substituting and see where you go. All right, so we're going to be using these formulas for subbing. So for example, in this first equation, I can replace x squared plus y squared with r squared. And I can replace y with r sine theta. So good news is I don't have any more x's and y's, and I have only r's and thetas. But the next step is our goal is to solve for r or r squared. So we want to isolate those. So how I'm going to start doing that is I'm going to factor a GCF of r out of these terms. And you can divide that r off of both sides. That leaves me r minus sine theta equals 0. And then just add sine theta to both sides, and you're at r equals sine theta. And I've solved for r. B is a different flavor, so I'm not going to just ask you to do that one by yourself because it's not similar to this one. We need a different approach. We're still going to just substitute for x and y. So for x, I'm going to substitute r cosine theta, and then times y, which is r sine theta. So now remember, we're trying to get r or r squared by itself. So I have two r's here being multiplied. I'm going to combine those into r squared. And now I need to get that by itself. It's being multiplied by cosine sine. So I'm just going to divide both sides by that. And it cancels on the left, and on the right I'm left with 2 over cosine theta sine theta. Now in this next section, we're going the opposite direction. We're starting in polar. We want to end up in rectangular. So in C, I have r equals 9. Now from the front of your sheet, we had r equals square root of x squared plus y squared. So I'm going to sub that in for r here. And then to get rid of that radical, I'm going to square both sides. And so that gives me x squared plus y squared equals 81. That's the equation of a circle with radius 9, which makes sense because r equals 9. So there's no more r's or thetas in my final answer. You also could have, in the very first step, squared both sides and got r squared equals 81, and then subbed for r squared, x squared plus y squared. Either one gets you the same way. All right, on this next one, I am going to begin by multiplying both sides by 1 minus sine theta. So on the right, those cancel. On the left, I have 1 minus sine theta times r. And what I'm going to do is distribute that through. And that gives me r minus r sine theta equals 5. And for r sine theta, I can substitute y. So I'm at r minus y equals 5, which is closer. I still have an r, though, that I need to get rid of. I'm going to go ahead and solve for r here by adding y to both sides, just to clean that up a little bit. And then now for r, I'm just going to plug in the square root of x squared plus y squared. And you could square both sides to get rid of the square root. That's going to cause a FOIL situation on the right, so we'll just leave it like this, because it's not wrong. It just makes me a little twitchy to have that square root there, but I can breathe through it. And then on this last part, we are going to graph this polar equation. I'm going to get you started and then ask you to pause the video to finish the table out yourself. So we are going to take, these are my thetas, and I'm going to plug them in to solve for my r's. So that I'm going to start with 3 plus 2 times sine of this first theta, so sine of negative pi over 2, which is negative 1, and 3 negative 2 makes positive 1. So if I were to go graph that, negative pi over 2 is here, and my radius of 1 gives me a point right here. So I want you to take a minute, pause your video, complete this table, and graph those points on your graph. Okay, here is my work. I do want to talk about this situation right here. I've plugged in negative square root of 3 over 2 for sine of negative pi over 3. The 2's cancel, and that leaves me with 3 minus square root of 3. So you will need to do that in a calculator. That gives me 1.3. So the 2's cancel where you see me with the scratch out in the red. That's me canceling the 2's. And I did have decimals here. And now I have plotted these points right here in black. And if you are using your reference sheet and comparing the A values, the A and the B value, you have that A over B, so it's my A and B, equals 3 over 2. That is less than 2 and greater than 1, which means my shape is going to be with a dimple in it. And so here's my dimple right here, and now it's just going to reflect over the y axis. So I'm going to have these points here. So it's didn't count. All right, so we're just going to draw that in. And that's it.